me go ahead and shine the light on it. And you guys can see what's happening there.
Yeah. Well, okay, I guess. Can we see what happened?
Well, you can see the thing spin, I guess is what I should
Yeah,
say.
well, see, I guess that was my question. Was it spinning or vibrating? But you said it's spinning,
No.
so.
Well, and it's just slowing down, and you can
Yeah.
count it, but it is spinning.
I didn't even see those things in there. I thought that was just like the thing behind it.
Okay, need to see it again?
Yeah.
All right.
If that's the case, then why can't things be light powered?
Solar panels.
They can. Google solar sails.
Or I guess
Solar
solar panels. What am I talking about?
Although solar panels
You're really excited.
don't move solid materials, they move electrical charge, and then use the electrical energy to move things. This is moving an actual
So
solid
the
piece
black
of metal.
side absorbs it all, and so I guess it's pushing it, is that it? And so like the aluminum on the other side just reflects it? I don't know. I
feel
thought it
like
would work the other way around.
It's some sort of like idea about this is a wave of energy. So
Do
it's
protons
slinging
have
into the
mass?
thing, so it has to have some sort of force or mass, and that makes
Or
it go
photons.
on. And
Wow,
it's
geez.
just you have to
Oh
have the
my
right
gosh.
material.
Don't
It's
like
okay,
it.
Mr. Bergman earlier
React
was
to
saying
that
photons for a
sensory
second.
integration or whatever.
Okay.
It's
Mr.
all
Bergman,
good.
do photons have mass?
I mean, they're
Well, that's
small,
kind of
but-
what we're after. If photons are particles, then it seems like they should have mass.
Hmm.
If photons are waves,
So they
then
wouldn't have
maybe
mass.
not.
Because electrons
does-
don't
But
have mass.
do they have to
but
have mass, or could they have force or energy without having mass?
You can't have it without mass.
Yeah, you can't. I don't see how you would.
Well, would you
Well, I
say
think
an
that kinda
electron
goes
has
against-
mass?
Yeah, it does.
Well, electron,
Okay, so then obviously it's acting as a particle.
electron doesn't have mass. It's the electron itself being pushed by something else that would.
Well,
Carry
electron
energy.
would have mass and then it can move to do things, right?
I thought the electron won't have mass.
Do electrons have mass?
1.6 or
Yeah, they do have mass.
Yeah.
Never mind.
Yeah, we used that number in one last.
Yeah, it's
Yeah,
like
it
really
does.
small.
And I don't want to let the discussion wander too far off, but that's the big question, or one of the big questions that's going on at CERN is what exactly gives something mass? And the Higgs boson was the thing that was mathematically calculated that if it existed, that was the thing which actually gives something mass. And so if you had it would be possible to have energy with no Higgs boson, and then you could have
Massless energy.
massless energy.
But then it would be
So-
energy without
So a
force.
photon without any Higgs boson could be energy no mass. A photon with Higgs bosons would be energy with mass. And you can tell by looking at this thing, this is kind of an antique. When they came up with this idea, this was long before the idea of a Higgs boson ever came around. So what do you think here? Is this kind of an indicator of mass or no mass for the photons, do you think?
I think it would be mass.
Well, see, I guess my question is, maybe I'm getting lost here, but
If they have
we have
mass,
energy.
do they go through the
but to have
glass?
energy, don't you have to have force, which would mean you have to kind of
Because
have
it would pass
mass
through the cloud
or-
space and
or-
then
That
That
Yeah.
makes
Force
sense.
to have
Is that
Okay,
I do.
I mean, a stick of dynamite contains energy.
okay.
Well, there's,
because in this? Okay, yeah, it has mass
Well,
well
it
because air
contains
particles have.
energy,
Yeah.
and when you release that energy, then it has
it's passing,
force.
because it would be the
It
photons
produces
passing
force.
through the
Okay.
clouds and atoms. Although some of them are going to stop in the nucleus.
Well, I'm saying that's
Of the
what's
glass.
affecting it, is the force and the energy, not so much necessarily the mass.
Didn't Albert Einstein say that energy and mass can be converted
Yes.
to each other?
Yeah,
So if you have energy without mass,
that seems
it's very likely that you could turn it into mass.
Yes.
Well, I mean, that's what they said about, like, atom, right? I mean, that's the whole idea of atomic bomb, that matter itself is kind of like solidified energy.
So with like the space-time continuum, or like that plane that he hypothesized, I guess. If you have massless energy,
I think
does that
everybody
mean it has no
is.
gravity?
Everybody at my table is.
Would not be affected by gravitational field.
So
I would not produce its own
it wouldn't
gravitational
cause
field.
any like
Ashley, come back.
deepening or
I know,
pushing down.
seriously.
Right.
Tell her. Tell her.
I don't know what that means at all. No, I'm just,
She'll be on the other side
how
of
would
this
that
video,
look
so.
like?
Let me
This is for
direct things a little
Ashley,
bit here.
come back.
Anybody notice the direction that that thing rotated?
It goes that way.
Okay? Toward or away from the black sides?
Towards the black side.
Away from the black side.
Nah, no.
Well,
Wait, it pushes the black side.
yeah.
Yeah.
Towards the.
Accelerates towards.
But it's Yeah.
the black side.
It accelerates from
Do it again.
behind.
Do it again.
Basically, so it reflects against the mirror. No?
I don't know.
No.
That's why I said like,
What?
it seems like it's pushing the
It
black.
seems like it's starting
Yeah,
on
it's
the,
pushing
like the
towards-
far side.
Which I don't like, cause I feel like, when I first looked at it, I thought it would be pushing the aluminum side, because it's like reflecting it off.
Yeah.
Well,
For
no,
some
see,
reason,
because
like, the-
black is gonna take the
Absorb
energy,
it.
yeah, take
Yeah.
the energy in so that it can drive it forward.
So that's
It's
just-
like you're feeding a gas line, like the gas comes in and the gas has to keep going.
I understand how it's just like on face value, I thought like if I punch you, right? Like we just straight like if I punch you, like he keeps on going, it reflects
It did
forward.
work. Like it did just like a little.
And think more on that idea. Think in terms of
You
momentum.
just gotta get right on it.
It's moving. It's going.
Barely, yeah.
Yeah, it's moving.
But see, the thing is, like, you gotta.
So think about the idea of conservation of momentum.
It's all the ways.
If something hits and
Creepy
sticks,
thing going off.
or if it hits and bounces,
Right here's Joel now.
which provides a greater force?
Hitting
Hitting and
sticks.
sticking or hitting and bouncing?
I'm
Sticking.
sticking.
Oh, bouncing, you taught us that.
Hitting and bouncing provides a bigger force than hitting and sticking. So why does hitting and bouncing provide a bigger force?
The equal and opposite reaction force.
What?
The equal and opposite reaction force.
Yeah, you provide a force when you hit it and it accelerates and comes to a stop, then you provide a second force to send it back in the other direction. You have twice as big a delta V if it hits and bounces as you do as if it just hits and sticks. Hitting and bouncing is a much bigger force involved than hitting and sticking, okay? Now,
So then why would we go counterclockwise?
well, here's where we're about to, if this thing were a pure vacuum on the inside, if they were able to get rid of all the air molecules entirely, it turns out that when these things operate, they will operate in the opposite direction. They will go away from the silvered side. Okay, so it's like the force is harder on the silver side. If there's any air in there at all, let me make sure I'm saying this right. If there's air in there at all, you get what we're seeing here, because this one has air in it. If you have a vacuum in it, if they move, they tend to move the other direction. What does the air have to do with it?
The air makes there be like more mass to be pushed, I guess, and so it's gonna move against.
It means that if you've got air in there, where your push is coming from is more from the air molecules than it is from the photons. So what happens is the photon comes in and hits this thing, and on one side the photon bounces off, on the other side the photon is absorbed. Now think in terms of temperature. What does that do?
It heats up the side that is absorbed.
Yeah, the
Black
black
side
side.
gets a little bit higher temperature than reflective side. So when the air molecules hit it, the ones that have more energy are the ones that hit the black side. And so if you have air molecules, they rotate in this direction. If you have very, very few or no air molecules, if you get motion, it will often go the other direction, okay? Because you get the bigger bounce off the reflective side.
If this was colder, we could make it go faster. Right? 'Cause I
No,
mean,
no, it goes slower
faster.
because
No, because energy, because
Right.
when the air is in it and it's still spinning, it's the fact that it heated
I'm
up.
saying the real effect is the fact that there's a temperature difference between the black side and the shiny side. And it's not so much whether the whole thing is hot or whether the whole thing is cold, but the black side is hotter than the shiny side. And because you've got that temperature difference between each side of the vanes, that's why you end up with a net force pushing it away from the black side, because the black side is warmer.
So is the mandatory vacuum or near vacuum the reason why this is impractical to make motion on Earth?
Yes. However, as I mentioned, Google solar sails.
They're working on it or something.
In fact, we have launched a spacecraft that has solar sail. I think we launched it.
Which is kind of like
It was
the idea-
they built it on an old Russian ICBM, and it was a private company that launched one that was going to travel through space under the influence of the solar wind. This is kind of the effect of the solar wind, where it hits on one side and you end up with a difference in force because of
Okay,
force
I
on
don't know
one
if
side.
they were thinking this in depth with it, the physics, but
Okay.
there's a Star Wars ship that looks like it's supposed to fly on that principle because it comes out of like the atmosphere and then it opens up this gigantic thing and accelerates.
That sounds, yeah. Go ahead and read what you've got there.
Oh, it just moved on me. Solar sails or photon sails are a form of spacecraft propulsion using the radiation pressure of a combination of light and high-speed ejected gases from a star to push large ultra-thin mirrors to high speeds.
So they're talking about using the force of light on a very, very large sail, because if you're in outer space, then you don't have that problem of air slowing you down. And the force would push, even though, you know, the force on a 1 square mile sail is probably only gonna be infinitesimal, it's gonna be very, very tiny, but it acts continuously for a long, 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 long time.
And you're never slowing down.
Yeah, and there's no retarding force, so your net force is in the direction of motion.
The only thing
And you
is-
can ultimately end up with huge velocities with very, very little in the way of fuel. So the problem is getting in outer space, get away from atmosphere in the first place, and have a big sail, but, you know, it's kinda like the old sailing ships, but using light as your wind.
And yeah, there's only two problems with that. You can only go in one direction, away from the sun, or the, whatever star you're at. And then I guess if you built up enough velocity in the solar system, that you'd still have the velocity to go traveling away from the sun. But if you got far enough away and you didn't have enough velocity to start with, like if you're trying to start at Pluto, you might not be able to go very far because like your light is less intense, your solar winds are dying
Depends
down.
on the area of your sail.
Yeah.
As far as the direction part, you can do other directions. It's like a wind sail, the angle of the light on the sail, the force acts perpendicular to the surface of the sail, so you can adjust your sail angle and tack as well. All right, so going back to your seats. And let's take this discussion
Like,
a little bit farther.
you'd think if she got away from school once a week that she would.
The
But,
next
alright.
are the next generation of sailors.
So the fact that the radiometer behaves differently if you have a vacuum on the inside kind of lends evidence to the idea that light then is waves. Because if it were particles, then it would behave very much the way we see it here all the time, but we were getting that effect because our particles were air molecules that were acting.